Hi, welcome to section 10.3, simplifying radicals, the distance formula, and circles. So we've got a lot to do in this section. Hopefully by the end of it, you all will be able to simplify radicals. You'll be able to use the distance formula to find the distance between 2 points. You'll be able to write equations of circles and graph circles given their equation. So let's talk about simplifying radicals. So the product rule, if you have things that are multiplied together and they have the same root, you can multiply them underneath the root. So like the nth root of a times the nth root of b would be the nth root of a times b. You can multiply those together. And with that division, the nth root of a over b would be the nth root of a over the nth root of b. We've done this before, but we're officially doing it now. Okay? All right, so conditions for a simplified radical. All right, so let's see, the radicand, so that's the thing underneath the square root, has no factor that's raised to a power greater than or equal to the index. The index is that in value, so you shouldn't have like a cube root and something to the 5th power because 5 would be greater than 3. Okay? Let's see, the radicand has no fractions, so if it has fractions, we've already separated them out, okay? No denominator contains a radical. That's a big one that we're going to have to deal with later, but our denominators shouldn't have radicals in them. That's not simplified form. And the last thing is that the exponents in the radicand and the index of the radical have no common factor other than 1. So sometimes what's helpful is to kind of convert them into that rational exponent form, and then we can simplify fractions, okay? So lots of things to deal with here, but let's get to it, okay? First thing we're going to do is practice multiplying some radicals together, okay? So in example A, I've got the square root of 7 times the square root of xy. You'll notice they have the same index. They're the same kind of radical. They're both square roots. So that means I can multiply them together. And when I multiply them together, they'd all just end up in the square root together. So I'm going to have 7 times x times y, so 7xy. Nothing simplifies out because I don't have any groups of 2 to take out. So I am fully simplified right there, and that's all I can do in part A. In part B, we've got the 5th root of 9y squared x times the 5th root of 8xy squared. So same type of radical, we have 5th roots, so same type. So that means that I can multiply everything together. And when I multiply, I'm just going to multiply everything. So I'm going to do 9 times 8, which is 72. Let's see, I'll have y squared times y squared, which would be y to the 4th. And I will also have x times x, which would be x squared. Let's see, if I break down the 72, I'm going to have 9 times 8, and 9 is 3 times 3. I'll have 8, which is 3 2's multiplied together. So really what's happening is I don't have any groups of 5 that I could take out. I don't have enough y's, I don't have 4 of them, so I can't take those out. And I don't have enough x's either. So all of these exponents are less than 5, so this is fully simplified, okay? I can't do any more to it from here. All right, how about some division? Okay, in example 2, we're going to have, the first one is the square root of y to the 8th over 16. So what we can do is just take the square root of each one individually. So I'll have the square root of y to the 8th, and I'll take the square root of 16. So y to the 8th, that's 8 y's multiplied together, okay? So sometimes it just helps to expand things out and see what you've got. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 y's multiplied together. With square roots, you're looking for groups of 2. So I'm just going to circle every group of 2 y's that I can. So I've got 4 groups of y's that I can take out. So that would be y to the 4th power. With the square root of 16, well, let's see here. 16 is 4 times 4, right? And each 4 is 2 times 2. So really, I've got 4 2's multiplied together to give me that 16. So I can take out 2 sets of 2's. And 2 times 2 would be 4. So the square root of 16 is 4. And that is my simplified answer for part A. In part B, I've got the cube root of 18 over 125. So I'm going to separate those. So that'll be the cube root of 18 over the cube root of 125. All right, the cube root of 18, there's not a lot I can do here. That's 9 times 2. 9 is 3 times 3. I don't have any groups of 3 that I can do anything with. So it just is what it is. It's going to be the cube root of 18. I can't simplify that. With the cube root of 125, though, that's 5 times 25, and 25 is 5 times 5. So we've got a nice little group of 5s right here. So we have 3 5s, so that is a group of 3, which is what I'm looking for. So the cube root of 125 is 5. That is my simplified form for part B. All right, now it's your all's turn. You get to try one and show me how much you've learned.